In 1790, Benjamin Franklin died. He was 84 years old. He had been an inventor, a diplomat, one of the founding fathers of the United States. And in his will he left one final lesson. Franklin bequeathed approximately £1,000 to each of his two favorite cities, Boston and Philadelphia. But with a condition. The money could not be touched. It had to be invested for 200 years. 200 years. In 1990, when the funds were finally opened, Franklin's original money had grown to approximately $6.5 million. From a few £1,000s to millions. Without anyone adding a cent. How is that possible? The answer fits in two words: compound interest. And today we are going to understand why it is the most powerful force in finance. And also the most dangerous. In the previous episode we saw what interest is, the price of time, the compensation for risk and for giving something up. But there is an enormous difference between simple interest and compound interest. And that difference changes everything. Simple interest is linear. Compound interest is exponential. And the human brain, which is designed to think in straight lines, is not prepared to understand what exponential means. Today we are going to see it. With numbers, with stories, and with a simple rule you can use for the rest of your life. Let us start with the basics. Imagine you lend €1,000 at 10% simple annual interest. Each year you receive €100 in interest. After 10 years you have received €1,000 in interest plus your original 1,000. Total, €2,000. Now imagine the same thing but with compound interest. The first year you receive €100 in interest. Identical. But the second year, the interest is not calculated on the original €1,000. It is calculated on 1,100. Because the €100 of interest from the first year are added to the principal. And now they generate interest too. The second year you earn €110. The third year, 121. And so on. After 10 years, with simple interest you have €2,000. With compound interest you have 2,593. The difference seems modest. But give it time. At 25 years, simple interest gives you €3,500. Compound, almost 11,000. At 50 years, simple, €6,000. Compound, more than 117,000. See what happens? Simple interest grows in a straight line. Compound draws a curve that starts off looking gentle and then shoots upward like a rocket. That is the nature of the exponential. It starts slowly, and then it explodes. In 1494, a Franciscan friar and Italian mathematician named Luca Pacioli, the same man who codified double-entry accounting, published a book called Summa de Arithmetica. And in its pages he included a trick that is still useful today, more than 500 years later. It is called the Rule of 72. It works like this. If you want to know how long it takes your money to double with compound interest, divide 72 by the interest rate. At 6%, your money doubles in 12 years. At 8%, in 9. At 12%, in 6. At 3%, in 24. It is an approximation, not an exact calculation. The mathematically precise number would be 69.3, but 72 is easier to divide in your head. And it works with surprising accuracy for interest rates between 2 and 15%. The Rule of 72 is one of the most useful financial tools in existence. And it works in both directions. It does not only tell you when your money doubles. It also tells you when inflation devours half your purchasing power. If inflation is 4%, your money loses half its value in 18 years. If it is 6%, in 12. If someone tells you inflation is 10%, know that in just over 7 years your money will only buy half of what it buys today. In 1626, the Dutch governor Peter Minuit supposedly bought the island of Manhattan from the Lenape people for goods valued at about $24 of the time. It is one of the most repeated anecdotes in American history. And economists have been using it for centuries to illustrate the power of compound interest. If those $24 had been invested at 7% compound annual interest since 1626, today they would be worth approximately $8 trillion. More than the value of all the land in Manhattan combined. Sound absurd? It is the mathematics of compound interest taken to its extreme. At 7%, money doubles roughly every 10 years. In 400 years, that is 40 doublings. And 2 raised to the power of 40 is more than a trillion. Obviously, nobody has maintained an investment at 7% for 4 centuries without interruption. Wars, crises, taxes, fees, inflation. But the exercise demonstrates something real. When time is long and interest is compound, the numbers reach scales that defy intuition. Franklin's legacy demonstrated it on a smaller scale, in a real experiment, not a theoretical one. The money grew impressively, though less than pure theory predicted. Because in the real world there are frictions, fees, imperfect investment decisions, bad years. But the underlying force remains. Compound interest is cumulative. It is patient. And it is unstoppable. Everything we have said so far sounds wonderful. Compound interest multiplies your money, makes your savings grow. It is the eighth wonder of the world. But there is a detail many forget. Compound interest works exactly the same way when you owe money. And in that case, it is not a wonder. It is a trap. Imagine you take out a loan of 10,000 euros at 20% annual interest. If you pay nothing, after 1 year you owe 12,000. After the second year, 14,400. After the third, more than 17,000. After the fifth, nearly 25,000. Your debt has multiplied by 2.5 without you receiving a single extra euro. This is not an abstract example. It is the reality of millions of people trapped in credit card debt with rates that can reach 20 or 25%. It is the reality of payday loans, those that promise easy money but charge effective rates that can exceed 1,000% annually. And it is the reality of student debt in the United States. More than 42 million Americans collectively owe around $1,800 billion in student loans. Many of these loans accumulate compound interest while the student is still at university. By the time they graduate, they already owe more than they borrowed. And the clock keeps ticking. Compound interest has no morals. It does not distinguish between the patient savings of Benjamin Franklin and the desperate debt of a student who just wanted to study. The mathematics are the same. The effect, radically different. In the 17th century, the Neapolitan banker Lorenzo de' Tonti proposed to the French government an ingenious financial mechanism. It would be called a tontine. It worked like this. A group of people put money into a common fund. Each year, the fund paid interest to all the participants. But when one died, their share did not go to their heirs. It was distributed among the survivors. The last survivor took everything. Tontines combined compound interest with something macabre, a perverse incentive to outlive your partners. They were enormously popular in the 17th and 18th centuries. The French government used them for funding. And they demonstrated something important: people intuitively understood the power of money that grows with time. But they also revealed the risks. When governments promised payments based on optimistic compound interest projections, they often could not deliver. The promises accumulated faster than the revenues. It is a pattern we will see repeated many times throughout this season. Compound interest is one of the greatest amplifying forces of economic inequality. If you have money saved, compound interest works for you. Your money grows while you sleep. The more you have, the more it generates. It is a virtuous cycle that accelerates with time. If you owe money, compound interest works against you. Your debt grows while you sleep. The more you owe, the faster it grows. It is a vicious cycle that accelerates with time. This means that compound interest, by its very nature, tends to separate the haves from the have-nots. Those who can save and invest accumulate more. Those who need to borrow accumulate more debt. It is not a question of merit or intelligence. It is a question of mathematics. And understanding those mathematics is the first step towards making them work in your favor instead of against you. 3 ideas to take away from this episode. First, compound interest is interest on interest. Unlike simple interest, which grows in a straight line, compound grows exponentially. At first, the difference is small. Over time, it becomes gigantic. Second, the rule of 72 is your tool. Divide 72 by the interest rate and you will know how many years it takes your money to double. It also works for calculating when inflation devours your savings. Third, compound interest has no morals. It multiplies the savings of those who can save, but also multiplies the debts of those who need to borrow. It is the most powerful force in finance. And it works 24 hours a day, 7 days a week, both for you and against you. Compound interest affects every loan and every investment. But there is one interest rate that affects all the others. It is set by a small group of people in a room. And when they raise or lower it, the consequences reach your mortgage, your car loan, and the cost of everything you buy. It is the rate that rules them all. And we will see it in the next episode.